Today's a big day. You finally learn rational exponents. What does rational again mean? Right, it means fractions. So we have fraction exponents. And we might as well just be right off the bat clear with that you don't get a calculator on this, on the test. So I think it's smart from the beginning to not use it. Don't use it on the homework. You should know these numbers, right? You should know these rules, so try and do it without a calculator. So first we go over what we already know about exponents. What happens when you multiply powers? What do? Right, you add the exponents. What do you do when you divide? Right, you subtract. What do you do when you raise a power to a power? You multiply, right? Those were like years ago that you learned that, right? Negative exponents, a little trickier, but I bet you know that they belong in the bottom. And here is the new one to the repertoire, the fraction exponent. Here we go. X to the 1/2 power, are you ready? Is the same thing as the square root of x. Stop it. Right? So, So rational exponent is just a fraction exponent. And whatever the denominator is of the fraction, so here it was a 2, becomes the kind of root. That's the rule. Whatever the denominator is becomes the kind of root. So if I have the 5th root of 7, this is the same thing as 7 to the 1/5 power. If I have the cube root of 5x, it's 5x to the 1/3 power. X to the 1/4 power. What if there's a power inside the radical? Like what about number 4? Right, this is m cubed basically to the 1/5 power, which we're going to write as m to the 3/5 power. Here I'm just going to write the whole thing, the 15 x2 y4 z5 all to the 1/3. I could distribute it 15 to the 1/3, x to the 2/3, y to the 4/3, z to the 5/3, but that's fine. So now we do it with numbers. And again, it's like things you should know, right? 9 to the 1/2 is the square root of 9, which is 3. No calculator needed. No work even needed to be shown. I'm showing the work. 27 to the 1/3 is the cube root of 27, which is 3. What about 27 to the 2/3? Now here you have a choice. You can either do the cube root of 27 squared or cube root of 27 squared. Well, I don't have a calculator, so which is easier? Cube root of 27 squared, 9. Or you might have just intuitively known that. Do you know the cube root of 64 off your head, top of your head? 4. So then here, negative 2/3. Negative 2/3. So this is going to be 1 over 64 to the 2/3, or 1 over the cube root of 64 squared, or 1 over 4 squared, or 1 over 16. And again, you might be able to do that in your head. If we have variables, so now we have variables, so this is the 4th root of m cubed n to the 5th, but can I simplify it? Yes, I can. I can take out an n. It's an even power, so there we have it. Now here, you're going to see the directions change. It's going to say write as a single radical expression. So I'm going to need to get a what? Common denominator, right? So the 6th root of a4b cubed. And it doesn't simplify, thank you. Or here, the 12 is going to be the common denominator. 4 12ths, 2 12ths, 5 12ths. And you don't even have to show this work. It's the 12th root of a4b2c5. Here it's got a common denominator, thank you. The 5th root of 6 squared y to the 8th. I can simplify, 5 goes into 8 once. And then I'm just going to make that 36, and I'd have 3 left over. No bars needed because it's an odd root. Now here, you might be tempted to multiply these numbers together. It's a big square root of 8 times 32 times 2. I wouldn't multiply them together. I would notice that that's a 64, and the square root of 64 is 8. So I have 8 root 8, but then that can simplify. My final answer, 16 root 2. There's a lot of ways to do that one. Okay. Last couple rows here. So this one I'm going to put a star by. This one throws people. You're going to, but once you see it, it's not bad. X to the what power? 2/6. What is 2/6 reduced to? Right, 1/3. What is 1/3? Cube root. It's like reducing a radical. And your answer, by the way, people will wonder, like, could I leave my answer like this? No. The answer always has to be in the radical form. It'll say that in the directions, simplest radical form. Now here it feels like, I can't really do anything until I think of 36 as 6 squared. Then it's the same problem as number 11. Just got a 6 instead of an x, basically. So the 4th root of 36 is the same thing as the square root of 6. 13 and through the end is going to use my exponent rules that we reviewed above. When you multiply exponents, you keep the base and add the powers. So it's 4 to the 2 root 2. Same thing here. Keep the base, add the powers. How do I add fractions? Oh, right, I need to get a common denominator. So this is 5 to the 5/6, but I always write it as a radical answer, so the 6th root of 5 to the 5th, and you can leave it like that. It would not be totally right to leave it as 5 to the 5/6. Number 15, I have a hint on the homework, and the hint says rewrite using rational exponents first. Then you got to be like, oh, right, I need a common denominator. That's 8/6. Keep the base, add the powers is 11/6. 6 root of 2 to the 11th. Can I simplify that? Yes, I can. I can pull out a 2, and then the 6th root of 2 to the 5th. And you could leave it like that, or you can make it a 32. Last row. This is division here, and division is keep the base, subtract the powers. So it's 6 to the 1/3, or the cube root of 6. 17 is the same problem, but you have to rewrite it first as rational exponents. Then keep the base, subtract the powers, which is 3/6 minus 2/6, which is 1/6, which is the 6th root of 5. So those are a little bit tricky, but you will practice them on the homework. You will get better at them. 18 powered to a power, I multiply the exponents. So if I multiply those two fractions together, don't I just get 5 to the negative 2, 1 over 25? And then the last two look like you can't do anything because the bases aren't the same. So I give a hint on the homework, rewrite as the same base. How could I rewrite 25 and 125 as the same base? Right, 25 is 5 squared, 125 is 5 cubed. So now that's back to keep the base, add the powers, 5 to the 5 root 3. How can I write 81 and 27 as powers of the same base? Right, 81 is 3 to the 4th, 27 is 3 cubed. Keep the base. I'm just going to write the answer here because if I show the work, I'll run out of room. 4 root 5 minus 3 root 5 is just 1 root 5. So this is not like the easiest assignment ever, but I help you through it and I give you a lot of hints. And as you do it, you get stronger at rational exponents.